Okay, hi. Welcome to assignment 3. It's on the stress analysis of the stress strain data. Hopefully, if you don't love solid mechanics, you don't need to know any of this. So I'm going to move through the tasks quite quickly. So we'll cover tasks 1 to 3 now, okay? So let's have a look. So task 1, it wants the area of the specimen. So let's do that. So the area, sorry, I'm not going to uncomment that. The area, it's a cylindrical specimen, and the radius is already given, so locked in here. So the area, or the cross-sectional area of a cylinder is pi. You can figure out that you can do pi in MATLAB like that, r squared. All right, next let's consider doing the strain. What does strain mean? We can go and read up here. Strain is epsilon, so it's the change in length divided by the initial length. Okay, so it might take a while to kind of understand how the data is written, but there's already loaded for you. Here is the displacement, the change in length given in meters. Okay, and here is the initial length of the specimen. So the strain should just be equal to what? The displacement, the change, that's the change of its length, which is already given here. So I'm just copying it here. So the easiest way is to highlight and copy and divide it by the initial length also already given. And I put semicolon not to print out. Okay, easy peasy. Next is the stress. So the stress is if you want to know a bit about solid mechanics, it's not the force that matters. Okay, here's the force from the data. Just to explain this here is that whenever you measure force, and even strain measurements, the initial value is often wrong. It needs calibration in the way that we measure forces and strains. So often when you load data, you have to remove the first element, the value of the first element from the whole data. So here we take the extension in length and remove the first value, which should be 0. It should be 0, but it isn't necessarily if the equipment isn't right, from everything. And the same with the force data. You take the whole vector of the force data here and you remove the first value. So this is the force newtons. And what matters for a material isn't so much the force, because the wider it is, the bigger it is, the more force it can sustain. What matters for the microstructure of whether it will be damaged is the stress, which is the force divided by the area. That's what the formula says up above. Where was it? It's the stress. Oh, why does it do that? Stress equals the force divided by the area. Okay, those are the first 3 tasks. Thanks for joining me.